do we think that we are really understood? No. So if you look at the SE Verma, he is really asking us to be alert once. Okay, now what all will give a charge? So this is the actually this will help us a lot to work out numericals or the next chapter capacitors. How the electric field due to this will be. So actually it produces, we know, so let's take the points. Okay, this will be P, this point. Let me take this point P. Let me take this is A, this is B. So what is the electric field strength at point A and B? So what Gauss law, what SE Verma is telling us, okay, there's an iron, there's a charged conducting plate. The surface charge density here is sigma. This is sigma. Don't write Q. If you want sigma, you write Q by A. Now, what he's suggesting is like a better think like this. Is telling the field, the charge which is present here, in fact, will produce field in either side. The charge which is present here will produce field in either side, and give the name 1, 2, 3, 4. Why the field strength at point P is 0? Because the field produced by 2 and 3, the resultant of that will be 0. That's why the net field is 0. What about the field strength at point 1, point A? Will contribute by 1 and 3. So here, what is EA bar? EA bar should be equal to due to E1 bar plus E3 bar. Now, this conducting plate, though it's a conducting plate, how do it appear? Non-conducting charge sheet. How the non-conducting charge should be? There'll be charge on one side and there won't be any charge on other side. So this charged conducting plate, shall I say, it is made up of 2 non-conducting charge sheets. All of you, please be alert if you are looking at anywhere here, there, because the whole chapter capacitors almost for 2 weeks we'll discuss based on this idea. The whole chapter capacitors just revolves around this one. Just be alert and try to understand. So we know like a this will be like a though it's an iron conducting plate. So how to charge? There's a charge here, there's no charge. So how to look at this surface? How it will be like a non-conducting sheet. It appears like a non-conducting sheet. Similarly here also, charge and no charge. If you can recollect non-conducting charge sheet, we shown like this only, no? Like a paper, non-conducting charge sheet. I think this was the method what we had. Non-conducting charge will be there only on one side. It is similar to that one. So this conducting sheet, what we should assume, it is made up of 2 non-conducting sheets. Don't say it's a non-conducting. How iron will become paper? How iron will become wood? Be used in terms of electrostatics. I'm talking here now. So this now. So what is a field strength at point A? It is contributed by 1 and 3. Okay, due to 1 how much? Sigma by 2 epsilon naught. This is I cap. Sigma by 2 epsilon naught, which is equal to sigma by epsilon naught I cap. The field strength. What is the direction of this? Like this here. Field strength at point B will contribute by 4 and 2. By 4, how much will be? Sigma by 2 epsilon naught minus I cap. By 2, sigma by 2 epsilon naught minus I cap. So sigma by epsilon naught. Now, what do you mean by negative direction? It will be towards left. Why field strength at point P is 0? I have very good reason for me. I have very good reason. So the field strength at point P, now I can justify. It's contributed by 3 and 2. Due to 3, how much it is? Sigma by 2 epsilon naught I cap plus sigma by 2 epsilon naught. This will be the correct explanation for this particular thing. So what is the conclusion? A isolated So what is the method? Whenever a conducting sheet comes, so what you should do, each face of a conducting charge sheet should be treated as a non-conducting sheet. This is a golden statement. Each face or surface, all right. Each surface of a charged conducting sheet will behave as a non-conducting charge sheet. To be frank, we don't know exactly how to find out electric field due to a conducting sheet. So what we are doing, I'm treating this as a non-conducting sheet and I'm working out why the net field at point P is 0. I can justify no. The field due to 2 and 3 is 0. You look at the same discussion what we made earlier. I forced you to accept net field inside the conductor is 0. Why 0? Because due to static charges, net field is 0. This was forcibly made you to think the field strength at point P1 is 0. Any reason for that? Net field inside the conductor due to static charges I forcibly added this idea. I just say, electrostatics, we did in conductor. Okay, accept. This is what we have done. So definitely other student development, he will not understand. He will come like this. Okay, field at this point is how much? Sigma by epsilon naught. Yes, sigma by epsilon naught. But when we do numericals, we need this one. Why field at point P 0? How come? How it has become 0? Any reason? Because this charge here will not produce any field. A question will come, no? The charge present. See, very simple. Don't come out of your stupid brain. So if a point charge is there, will it produce field at 1? Yes. Will it produce field at 2? Either way, no? Just logic. Some students are asking, sir, why this C bar? Point charge is there, Coulomb's law. The field will be there only at 1 or only at 2 or both at 1 and 2, both at 1 and 2. Similarly, a charge present here, what it does? It produces field here and here. Same thing, the charge which is present here will produce field here and here. How come net field is 0? Because the resultant of these two will become 0. Any doubt if you want to clarify? Any doubt if you have, you can clarify. Okay, there's a logical thinking. Oh. I'll take it of this. Okay, now we'll go for the application part. So I put that golden statement. This is something very, very, very important. I'm telling this one. The whole chapter, I'm saying one chapter, not few problems. So what you should do